Hey y'all, Professor Wyman here. I'm just going to go through writing out the results in APA style notation and then in paragraph format for chi-square test for independence. So if you don't know how to run that test, you can go back a couple videos to where I talk through that. This is the format that you're going to use. So you can see, as always, with our notation format, we start with the type of test statistic, which in this case is a chi-square. And then we're going to talk about the degrees of freedom, and then also the sample size we'll report. The sample size is important for chi-square because your p-value becomes more accurate of an estimate with the more people in your sample. And then we also are going to report the actual chi value, the p value. As I've talked about in other videos, you should report the actual p value number, not just less than or greater than 0.05, unless it is very small. And then you could say 0.01, less than 0.01 or less than 0.001. Otherwise, just say p equals the number. And then report the Kramer's V. If you have a 2x2 ANOVA, sorry, 2x2 chi-square test for independence, with two variables that each have two categories. You could also instead report Kramer's, or you could report the phi coefficient. I just tend to use Kramer's V. So now this is where we get our notation information from. So we're going to get our chi-square we have here, our degrees of freedom. We're going to take this 2. So that's going to be a 2. And then n is going to be our sample size, which is 35. So we would say n equals 35. And then this is our actual chi-square value, which is this guy right here. So 1.43. Our p-value, and again, I'll talk about the Fisher's exact test in the next page or in the APA paragraph, but I'm just going to use the p-value from the chi-square since that's what we're reporting. So I'm going to say 0.49. And then I'll report the Kramer's V. Again, the phi coefficient does not work if you are looking at more than a 2x2 contingency table. So we have a 2, 1, 2 by 3, 1, 2, 3. And so our Kramer's V is going to be this 0.20. So now we're going to write that out. So this is written out in APA style. You can see that I have a Pearson's chi-square test for independence. You don't have to have Pearson's in there. You can just say chi-square test for independence was conducted to examine the relationship between first generation status. So we're just identifying our variables. So there's that first generation status, pop quiz reaction. You could certainly talk about the different groups that are in there. So you could get more detailed with this. This is just kind of the key information to include. And then we found no significant relationship, chi-square. All of that information from our notation just goes right at the end. So that would be fine. You could also refer to a table, and I'll show that in the next video, talk about how to create a chi-square test for, or chi-square table for APA style. This is indicating that any differences that you found or any relationship you found is just sampling errors. There's not really any point in showing those differences or relationships that you found by chance. But if you wanted to, you could create a contingency table to show the descriptive statistics. Now, the other option is that because we had a cell that was had a less than 5 for the expected frequency, you could actually go ahead and report the Fisher's exact instead. So you'd only do one of these. You would choose which you wanted to report. So a Fisher's exact test was conducted to examine the relationship between first generation status, ignore that second between first generation status and pop quiz reaction. And then I just put, due to small expected cell frequencies, we use Fisher's exact test. So again, in this example, we fail to reject the null hypothesis, and Fisher's exact is not going to find the opposite. And so you could still report the chi-square. You could also report the chi-square and then say that you also conducted a Fisher's exact test and found no difference in the end result. In this case, the end result is just that you report that there was no not statistically significant, so there's no relationship between them. And then you'd report your p-value. There's no test statistic for a Fisher's exact test. It just gives you an exact p-value for finding that chi-square value or finding that relationship. And so this test is just an alternative that is more conservative, um, meaning it's harder to you're less likely to make a type 1 error. It's harder to find a statistically significant difference when there isn't one. So this would be either of these would be acceptable. And the nice thing about it is in Jamovi, you don't have to do a lot of, you're not doing any calculating. You can just click Fisher's exact and see if it's different. And then, you could talk about both of them, and that's quite simple to do. And so that would be, really up to you as far as what you're reporting. You just want to make sure to identify that assumption of having at least 5 expected frequencies for each cell was violated, and then talk about what you did to adjust for that. So that's the end of this video, and I do have one more that just talks about how to make the contingency table in APA style.